Hi everyone. Now we are going to discuss about transformers. First, let us discuss about the definition of transformer. Transformer is a static device which transfers electrical energy from one circuit to another circuit without having any electrical contact by the principle of mutual inductance. Transformer is an AC device which is used to change high voltage low current AC into low voltage high current AC and vice versa without changing the frequency. That is, the transformer which transfers electric power from one circuit to another circuit without changing the frequency with the principle of electromagnetic induction. That is, it will work in the principle of mutual inductance. This is the principle of operation. Here the transformer works based on the principle of mutual inductance. Here, according to which an EMF is induced in a coil when current in the neighboring coil changes. And let us discuss about the construction of transformer. So here the construction consists of cell type transformer. In this cell type, we can see the windings are wrapped around the center leg of the laminated core. The next type is core type. In this, windings are wrapped around two sides of a laminated square. And you can see the sectional view of the transformer here. And this is sectional view of the cell type transformer, and this is sectional view of the core type transformer. Here, high voltage conductors are smaller cross section conductors than the low voltage coils. And this is the construction of transformer from stampings, like E stamping. This is an E stamping and this is an I. With the help of this stampings, and this is, we can see the two L stampings here. So this is with the help of an I and E stamping, we can make a cell type transformer, and with the help of two L stampings we can make the core type transformer. And this is the coil and laminations of the core type transformer. And this is the cell type transformer. In the cell type transformer, the H and HV and LV windings are split into number of sections, where HV winding lies between two LV windings. See here you can see HV winding lies between two LV winding. Here you can see HV winding slide in between two LV winding. In sandwich coils, leakage can be controlled. Okay. This is the cut view of the transformer. You can see the windings here, and this is core, and this is tank. This is the radiating tubes over which the gas, air or water can be passed to radiate this to cool the oil. And this is the conservator tank, and this is the high voltage terminal, and this is the low voltage terminal where the output can be taken. And this is a transformer with conservator and breather. So you can see the conservator and breather here. So here this conservator tank, what is the use of this conservator tank is, when this oil is expanded, it get heated and expanded, and it will fill in this conservator tank up to this level. And if it is the oil level is reduced, and this oil from the conservator tank can be sent to the transformer tank. This conservator tank otherwise called as expansion tank also. So this transformer tank is fully filled with the transformer oil. This oil acts as an insulator, and you can see the core here, and this is windings, and this is the breather silica gel. So it will absorb the moisture content in the from this tank, humidity. It will absorb the humidity. And let us discuss about the working of transformer. When current in the primary coil changes, that is being alternating in nature, changing magnetic field will be produced. This changing magnetic field get associated with secondary to the soft iron core. That is, while passing an alternating voltage, when supplying an alternating voltage here, a current will flow through the primary winding. That current will produce a flux. That flux will link with the coil, link with this core, and that flux will again from the core, it will link with the secondary winding, and this core will induce an EMF, that is secondary EMF. If it is a closed circuit, then the secondary EMF induced in the secondary side will produce a current. And this is the single phase transformer. Here you can see the two winding coupled by a common magnetic core. This is the supply voltage what we are passing, and this is the current in the primary side, and this is the induced EMF in the primary side, and N1 represents number of turns in the primary side, and here and the flux from the primary side links with the secondary side. In the secondary side you can see the N2 represents the number of turns in the secondary side, and E2 represents EMF induced in the secondary side, and this induced EMF will pass a current I2 flowing through the secondary side. If it is a closed circuit, as I said earlier, it will pass the secondary current through the load, and there will be an EMF, voltage across this two terminal. It is called the terminal voltage across the secondary. And the next one is ideal transformer. So these are all the characteristics of ideal transformer. So first one is zero leakage flux. Flux is produced by the primary and secondary currents or confined within the core. That is, we are assuming that there is no leakage flux in the ideal transformer. And the next characteristic is the windings have no resistance. Induced voltages is equal to applied voltage. And the next one is the core has infinite permeability. Reluctance of the core is zero. Negligible current is required to establish magnetic flux. And the next one is lossless magnetic core. No hysteresis loss or eddy current loss. So but we cannot make a perfect 100% efficient transformer in real. There will be a losses in practical transformer.